Section 6.4 continued. Solving polynomial equations by factoring. We have done that in past sections. What we're going to do here is add another property to our factoring, and our property is the sums and differences of cubes. If I have a binomial and my first and last term are both perfect cubes, I can then have a format to factor those. Here is a sum of cubes. When that occurs, I'm going to take the cube root of A and the cube root of B and put that in the first binomial, and that will be with a plus sign. Then I will take that term from my binomial, A squared. I will take B and square it for the last term, and my middle term will be A times B with a minus sign. Very similar to that is our difference of cubes. And here I'm going to take the cube root of my first term. That'll be A. The cube root of my second term, which will be B. And then that will be a minus sign. And then my trinomial set up from that binomial will be A squared, A times B for the middle term, and then B squared for the last term, with these both being sums. So what we're going to take a look at is some practice on these two forms, also some practice on our other forms and techniques of factoring. And then we're going to actually solve polynomials by factoring with all of our forms. Let's begin. Here I want to factor each expression. Notice I brought over the forms for my sum of cubes and difference of cubes. Here, my first term is 8x cubed. So my A for my difference of cubes is going to be 8x cubed. A is equal to 8x cubed. My B would be a 1. I just know it's a difference, so I'm going to use this format. Therefore, I need a binomial, and my A is taking the cube root of this, so the cube root of 8x cubed is going to be 2x. 2 times 2 times 2 is 8. X times x times x is x cubed. Then I'm going to have a minus sign because I have difference of cubes. And the cube root of 1 is 1. Now I set up my trinomial, and I need a squared. A squared is going to give me 4x squared. There will be a plus sign, and that will be A times B. Ignore the minus sign. A is 2x, B is 1. That will give me 2x times 1 is 2x, plus B squared, which would be 1. Now, if I would distribute back through and simplify, I would end up with my original expression, which would be 8x cubed minus 1. Let's do the same procedure on my next example, except here I have a sum of cubes, and I need to find the cube root of my first term. Here my A would be 27y cubed. That would be 3y. My B would be the cube root of my second term, which is 8, and that would be 2. And since this is the sum of cubes, my first term is a plus sign. My first term of the trinomial is a squared. My A is 3y. Therefore, when I square that, that's 9y squared. My middle term is A times B. Therefore, 3y times 2 is 6y. And that's a minus. And my last term is B squared. B is 2. B squared is 4. And that would be a plus sign. And if I would distribute each term through the trinomial and simplify it, I would end up with my original polynomial, 27y cubed plus 8. Let's take a look at a couple more examples. Here I have a difference of cubes. My first term is a perfect cube, and my last term is a perfect cube. So I have a difference of cubes, so I need a binomial of A minus B. Here the cube root of A would be x, and the cube root of my B, which is y cubed, would be y. And with a difference of cubes, I will have a minus sign in that binomial. Now I need to set up my trinomial, which is going to be A squared. A is x, so that would give me x squared, plus A times B, which is x times y, or xy, plus B squared, which is y squared. And again, if I would distribute each term through my trinomial and simplify it, I would end up with my original polynomial. Our second example on this screen is 64y cubed plus 1. My A is a perfect cube, and my B is a perfect cube. I'm going to use the sums of cubes. And I need my binomial. The cube root of a, which is 64y cubed, is going to give me 4y. The cube root of b, which is 1, is going to be 1. And in my trinomial, with a sum of cubes, that's going to be a plus sign. Now I set up my trinomial. I need to have a squared. So 4y squared is going to give me 16y squared. I need a times b, which is 4y times 1, which is 4y. And that would be with a minus sign for sums of cubes. And I need b squared, and that would be 1 squared, which is 1, and that would be with a plus sign. Again, if I distribute each term through the trinomial and simplified, I would end up with the original expression. Let's continue with some more examples of factoring. I kept our sum of cubes and difference of cubes here as a reference. So let's take a look at our first example on this page, x to the fourth minus 12x squared plus 27. This follows our pattern in such a way that we need to have two sets of parentheses that will break this into two binomials. There's not a GCF in each term that I can factor out, but I can break up x to the fourth into x squared and x squared. And I know that I need to add the two factors that give us 27 to make a negative 12. And that would be 9 and 3. And that would either be minus minus or plus plus, because this is a positive sign. And since it's negative, it's going to be a minus minus. That gives us x squared times x squared is x to the fourth, minus 9x squared minus 3x squared is minus 12x squared, and a negative 3 times negative 9 is a positive 27. I recognize that I have a difference of squares in my first binomial, and that would be x plus 3, x minus 3 for this difference of squares, and then I just bring down x squared minus 3. This is not a difference of squares because my second term is not a perfect square. My next example on this slide is a difference of squares. It's a binomial, and each term is a perfect square. Therefore, I'm going to break that into two sets of parentheses. Take the square root of the first term, which is going to give me 4y squared and 4y squared. And my second term, again, is a perfect square. That's going to be a plus 1 and a minus 1. Now I'm going to bring down my first term. And I realize that my second binomial, again, is a difference of squares. So I'm going to set that into two sets of parentheses. Take the square root of that first term, which is going to be 2y and 2y. My second term breaks up into 1 and 1, and again, plus and minus. Now this is factored completely. On my next example, I first see that I have an extra x in each term, therefore I can factor out an x as a GCF. When I do that, x to the fifth divided by x is x to the fourth. 17x cubed divided by x is 17x squared. And 16x divided by x is going to give me 16. Now I have a trinomial that's set up in the usual pattern, so I'm going to break that into two sets of parentheses. That gives me x squared and x squared. Now I need to break up 16 into such a way that the factors add to give me my middle term and multiply to give me 16. That would be 16 and 1. And since it's a negative, that would be minus minus. Now I realize that each binomial is a set of difference of squares. So I'm going to bring down my x and break the first binomial into two sets of parentheses, which would be x plus 4 and x minus 4. And then my last binomial be broken into another set of parentheses, or two sets of parentheses, which would be x plus 1 and x minus 1. Remember, we just have to factor completely, starting with looking at the GCF, and then looking for any other patterns that we have, being it sums or difference of cubes or difference of squares. Let's take a look at our next example. I always like to have my greatest degree first, and if I do that and change the order, my first term is negative, so what I'm going to do is factor out a negative 2x out. Negative 128 divided by a negative 2 is going to give me 64. X to the fourth divided by x is x cubed. A positive 250 divided by a negative 2 is a negative 125. And x divided by x cancels, and I'm left with just a negative 125. Now I recognize that I have a difference of cubes. I bring down my negative 2, x, and I put down two sets of parentheses. One for my binomial, one for my trinomial. Since I have difference of cubes, I have that format on the screen. I need a, which is the cube root of my first term, which is going to give me a 4. X. I need my b, which is the cube root of my last term, which is 5. And since it's difference of cubes, that's a minus sign. Now I need a squared, which is going to give me 16x squared, plus a times b, which is 20x, plus b squared, which is a positive 25. And it's positive because in our format, that's what it should be, a positive. And here, this is factored completely.